In this video, we will find the inverse of a function using an algebraic approach, and we will check our answer using a graph. The function f of x is given as 2 over 3 plus x. We're asked to find its inverse and to check our answer. We're going to graph f inverse, and y equals x when we're checking our answer. So to find the inverse of this function, f of x, remember we start by just writing it as y equals 2 over 3 plus x. Now I know that my first step is going to be to switch the x and the y, but I am noticing that I'll have, I can just write this as a fraction, y over 1 equals 2 over 3 plus x. That way it'll be easier to cross multiply. Okay, so I want to switch my x and my y because I'm finding the inverse. Now that I've done that, let's cross multiply. The numerator of the first fraction times the denominator of the second is equal to 2 times 1. So remember, with equivalent fractions, cross products are equal. So I can now distribute that x, and I get 3x plus xy equals 2. I want to solve for y. Let's subtract 3x from both sides. To solve for y, I'm going to divide by x. I can now simplify this down to y equals negative 3 plus 2 over x. Of course, we know that x cannot equal 0 here, right, in the domain. So the f inverse of x, I have solved this problem. My claim is that it equals negative 3 plus 2 over x. Now I want to verify my claim by using a graph. First thing I'll graph using a utility like a graphing calculator or Desmos or GeoGebra is the function f of x, 2 over 3 plus x. Notice there is a restricted value in the domain at negative 3. Because if x were negative 3, you'd have division by 0. That's why x does not equal negative 3. Now using Desmos, I will graph f inverse of x, which is negative 3 plus 2 over x. And remember we said there would be a restricted value at 0. The next thing I'll graph is my line y equals x. And I'm observing that the red function and the green functions are definitely reflections across the line y equals x. So my conclusion is because f of x and f inverse of x are reflections across the line y equals x, then they are inverses.